Hello class, so objective is hopefully you are now learning how to solve momentum problems. Alright, so first step, read the problem, try it on your own, and then after you try it on your own, go ahead and come back to the video. Alright, so some kids are dropping books off the Bay Bridge into the water. A 1.5 kilogram book, its initial velocity upon hitting the water is 25 meters per second downwards, and it comes to a stop 1.5 seconds later, before starting to float upwards. So it will eventually go up. So what is the change in velocity between the time the book hits the water and the time it comes to a stop? So it stops 1.5 seconds later. If it stops, we know, oh, its final velocity is 0. Its initial, or V naught, is 25 meters per second. The change in velocity is V final minus V initial, so it'd be 0 minus, oh, and this is a negative, so it's minus 25 meters per second, or it would give us a positive 25 meters per second. That's our change of velocity. It was negative, it stopped, so it's less negative than it was before, making it more positive. Alright, B, now let's turn to a free body diagram while it's sinking. So we can think of it as we have a book, and now my water's red, now my book will be blue. It has a book, and it hits the water at 25 meters per second. Then it's going to kind of sink downward some more, and then float back up to the surface. At this point, it's going 0 meters per second. And we know that if it's going to go back up, there has to be some force going up. So there is a force of gravity, but there is a larger force of buoyancy, so it'll make it float back to the surface. So this would be your free body diagram. So there is a part C and D to this. So here's part C and D of the same problem. So it's still our book. We know that our change in velocity is a positive 25 meters per second from A. We know that we have some force downwards, but a larger buoyancy force up. So now it says find the net force that is acting on the book over the period of time it is working. So this would be using our equations, talking about more. So like our current equations, which would be, we'd have impulse is equal to force times delta t. And we also know that J is also equal to the mass times delta V. And if you look back at the initial part of the problem, in kilograms, or your mass is 1.5 kilograms. So we know the mass of the book, we know the change of velocity of the book, so we can find the impulse. So J is equal to 1.5 kilograms times our delta V, which is 25 meters per second. Multiply it, and you get 37.5 kilograms meters per second. And we know this is also equal to F delta T. And we know our total change in time, if you look back at the problem again, was 1.5 seconds. We know we want to find our force. We have 37.5 kilograms meters per second. Divide by 1.5 seconds on both sides. And our force ends up being 25 newtons. So the net force between the gravity and the buoyancy. Alright, so you know that the total sum of all forces in the y direction equals 25 newtons. That's our net force. And you know that the things that you're adding this is, you know, the force of your water by the book, which would be your, think about it as your F buoyancy, minus the force down would be your Fg. So you know that 25 newtons is equal to your force B minus Fg. And hopefully you remember Fg is equal to mg, and we know the mass is 1.5 times 9.8, or I'm going to do 10 because I'm doing mental math. So it would be 15 newtons minus Fb gives us 25, so I want to know what this is. If you move this over, we get B is equal to 40 newtons. Alright, so hopefully this helped you solve some more complex momentum problems. We'll continue talking about momentum tomorrow and for quite some time, so make sure to bring and show your homework and be ready for tomorrow.